Okay, so today we're going to be working on ECT, so engine coolant temperature and intake air temperature sensors. So we went over to all data to see if it worked the same way it does that we talked about, and it does. So it'll focus. So we use so it's the same. It's a variable resistor, and then as temperature goes up, the resistance in it will go down, sending a different voltage to the PCM. So we couldn't find anything on all data about this graph we were looking for. We looked for a little bit. So we did find something on a forum. I'm not sure how accurate it is, but it gives us some kind of starting point. So we'll go off of that and see what happens. This is a picture of before we warmed up the engine. You can see that both the IAT and the ECT read about the same at around 70 degrees or 69.8, and they read about the same voltage at 3.94 volts. So this is a picture after we warmed up the engine. You can see that the ECT is at about 195.8 degrees Fahrenheit, and it reads about 1.06 volts, so it's right at operating temperature, and the IAT is reading 89.6 at 5 volts. The only thing is that 5 volts is a little high for that, but this was actually when we unplugged it, so that's why it's reading 5 volts there. Okay, so we're testing the resistance of our intake air temperature sensor. So we have 0 ohms. We got a little duct tape boat of snow here because of the southern Illinois weather. So we just warmed up the engine. So we're at about 9.94 kilo ohms. We get it. And then if we put it in the snow, the resistance should go up from there because it is a negative coefficient thermistor.
See it at 122 degrees. Voltage went back up to get a more accurate reading of the circuit.
So it's already above 10 kilo ohms, and it's still going up. You just leave it sitting in there and see what it gets up to. Yeah, because we're going to come back later and see how cold it gets. So only like 2 or 3 minutes later, we got a little bit of a better setup, but we're already at 36 kilo ohms, which is, like more than tripled, and it's still going up very slowly. So now we're going to go the opposite direction. So we got a heat gun, we got our air temperature sensor there, so we're just going to put it on low and watch it heat up. So resistance is going down in this case because temperature is going up. It's the opposite of what we did with the snow. Okay, so once we were done messing with the sensors, we ran codes. We're going to clear those, and then we also put everything back where we got it from. It's always good to make sure that when you take anything apart, you always put it back together, make sure the vehicle runs right. So the intake air temperature sensor, that's back where it's supposed to go, and the engine coolant temperature sensor down there, that's where it's supposed to go right there. So, yep. Okay, so we are back in the Jeep Cherokee, working on throttle position sensors today. So we've got our scan tool, and we can see we've got absolute throttle position sensor percent, and that is on our list. It's going to be number 3. So then we're going to click enter, and we can see that right now it says it's 94.9, so it's at the moment closed. So then as we put the accelerator in, it doesn't do anything, but it's also not on at the moment. So well, there we go. So so it's at 12.5, and then we'll we push it in, and it goes up to 79.6. Or 12.2. You can see it slowly rise. As long as it's going slowly and consistently up, we know that it's good, and there's no wear spots in the resistor.
So this is our wiring diagram for our throttle position sensor. We have our 5-volt supply that's coming from the PCM. It is an orange wire, comes all the way to the top. And then we have our sensor ground right here. It's a black light blue tracer. It's grounded to the PCM as well. And our throttle position sensor signal, which comes down and it splices off to the TCM and goes back into the PCM. So we have our orange wire right here in this first terminal. It is our 5-volt supply. And then we have our orange with red tracer that's in the middle right here. It's our throttle position sensor signal. And then we have our black with light blue tracer right here, which is our ground. We have our 5-volt supply, which is terminal 1. It's an orange wire right here. And our throttle position sensor signal, it's red with or orange with a red tracer. And then our sensor ground is black with a light blue tracer. So if we head over here, we've already pinned into our ground. See, it's showing negative source voltage, which this battery is a little dead, so that's why it's at 8 volts. And then we can switch these over. And as we go here, this is our red wire, which is 5.2 volts. And then as we go into our sensor signal, we get about 4.7 volts because the sensor is disconnected.